Alright, this better be recording this time. Hey guys, my name is William and I'll be your speaker today. Welcome back to part 2 of Geometry Bootcamp, the very last episode of Geometry Bootcamp, our very first geometry lecture of this new geometry series. As always, we're so excited to have you here with us, and if you haven't watched part 1 of this lecture yet, please be sure to check it out right here. Alright, now let's get started. In part 1 of Geometry Bootcamp, we discussed these 4 main concepts. First of all, geometry is the study of shapes through proofs and statements. Throughout this series, we'll be going over several proofs and practice problems with you guys. Next up, we define terms and postulates related to one-dimensional and two-dimensional space. This includes figures such as points, lines, line segment variations such as rays, line segments and lines, as well as planes. Alright, now on to part 2. We've already covered the basics about space in part 1. Now, let's move on to angles. I'm sure you guys all know that angles is a very important concept in geometry. Well, an angle looks like the figure on the right. It's a combination of two rays that share a common endpoint. But how do we actually name them? Well, this is where the vertex comes in. In this diagram, the vertex, or the common endpoint formed by the two rays that form this angle, is labeled as point Z. The angle itself is named as 1. Therefore, the names for this angle could be angle 1 or angle Z. Since there's an extra point on each of these two rays that form the angle, namely points X and Y, we can name this angle XZY and angle YZX. Also note that Z, the vertex, must be in the middle when we're naming angles. Therefore, we can't name this angle ZYX, ZXY, YXZ, or XYZ. Alright, now that we know how to measure angles, no we don't. My bad. Okay, now that we know how to name angles, how do we actually measure them? Well, angles are measured in degrees, and the maximum angle measured is 360 degrees. There are 5 angle types: acute, right, obtuse, straight, and reflex angles in order of increasing measure. Acute angles have a measure of between 0 and 90 degrees. Right angles measure to 90 degrees, while obtuse angles are measured between 90 and 180 degrees. Moving on, straight angles are always 180 degrees in measure, while reflex angles have angle measures between 180 degrees and 360 degrees. Just be sure to remember that angles cannot have a measure that is greater than 360 degrees. Alright, let's move on to different angle pairs. Here are the 2 major angle pairs that are related to degree measure: complementary and supplementary angles. Complementary angles are 2 angles that sum up to 90 degrees. On the other hand, supplementary angles are 2 angles that have a sum of 180 degrees. These angle pairs can be seen in the diagram above. Now onto adjacent and vertical angles. Adjacent angles are angles that share a common side but do not overlap. In this case, as seen in the diagram on the right, the adjacent angles are angles 1 and 2, 2 and 3, 3 and 4, and 4 and 1. In this case, if you haven't noticed yet, these angles are also supplementary. Vertical angles, on the other hand, are congruent angles that are opposite of each other when 2 line variations intersect. Examples of this angle pair from the diagram on the right are angles 1 and 3 and angles 2 and 4. Angle bisectors are line variations that essentially divide an angle into 2 angles with the same degree measure. As seen in the diagram on the right, the angle is split into 2 congruent angles by a ray. This ray is an angle bisector. Alright, now that we've covered basic angle pairs, let's move on to postulates for angles. The angle addition postulate states that the sum of the measures of 2 adjacent angles is equal to the measure of the angle created by the non-common sides of these 2 adjacent angles. Essentially, just add the 2 measures together to find the measure of the bigger angle. That's it to this postulate. In the example on the right, you can see that angles ADB and BDC have angle measures of 21 and 63 degrees respectively. If we add them together, we can find that the angle measure of angle ADC would be 21 plus 63, which is 84 degrees. Next up, the linear pair postulate. If 2 adjacent angles form a linear pair, this means that they are supplementary. This example is replicated on the diagram on the right. Alright, now that we've covered the basics for angles, let's move on to the distance and midpoint formulas. So to understand these 2 formulas, we have to first understand the coordinate plane. The coordinate plane is a two-dimensional plane formed by the x and y axes. These two axes are perpendicular to each other and also intersect at the origin, which is point 0, 0. This also separates two-dimensional space into 4 quadrants, as seen in the diagram on the right. Coordinates are also labeled with their x and y positions. So for example, the origin is labeled as point 0, 0 because it is 0 on the x-axis and also 0 on the y-axis. Alright, now let's talk about the distance formula. We can use this equation to find the direct distance between any 2 points on the coordinate plane. Let's say that the 2 given points have coordinates of x1, y1 and x2, y2. The distance between these 2 points, or d, would be given as the square root of x2 minus x1 squared plus y2 minus y1 squared. We can also use the same points to find the midpoint between these 2 points. The midpoint of these 2 points, or xm, ym, is given by x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So even though these formulas can be kind of intuitive at times, be sure to try them out on practice problems. Moving on to our final concept of Geometry Bootcamp, properties of equality. Let's start with the 4 basic properties of equality: addition, subtraction, multiplication, and, you guessed it, division. If 2 variables or values are equal, in this case variables a and b, then these properties of addition, subtraction, multiplication, and division can be applied. If 2 values or variables, in this case variables a and b, are equal, then these properties of equality can be applied. These concepts should be pretty intuitive, but you'll use them frequently in proofs. Other properties of equality include the reflexive, symmetric, transitive, and substitution properties of equality. These properties essentially describe the ability to replace equated variables in proofs. Again, although all of this might seem kind of intuitive, these properties of equality will become very useful in proofs later on. Alright, let's sum up what we learned today. We first talked about different angles and angle pairs and discussed their properties and postulates. Next, we looked at the coordinate plane and the distance and midpoint formulas. Last but not least, we looked at properties of equality, which will become very useful in proofs. And that's it for today's video. Thank you guys so much for attending today's lecture, and as always, we hope to see you in future videos.